Hey guys, one of the skills you learn in Algebra 1 is how to simplify radicals. And this skill gets used throughout geometry the entire school year. So we need to be really good at it. And before we're really good at simplifying radicals, we have to make sure we know our perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, the list continues. We need to break apart our radicals using those perfect squares. If you need to go back, write those numbers down before we get forward, go for it and join me. The way we break down radicals is we break it apart using the greatest perfect square that divides into the radicand. The radicand is just the fancy word for the number that's underneath that square root symbol, the radical symbol. So for example, the first one, square root of 4. That's easy. 4 is a perfect square. Square root of 4 is just 2. Whereas the next one, square root of 6. 6 is not one of those perfect squares. And when I think about my perfect squares, I have to think about, can 6 be divided by any of them? Well, everything's divisible by 1, so 1's not going to really matter. But 4, does 6 divide by 4 nicely? No. And the next one's 9. So it doesn't look like 6 can be broken down any further. So square root of 6 is just radical 6. How about 8? 8 is not one of our perfect squares, but think about your perfect squares. 4. 4 divides into 8. 4 times what is 8? 2. So I would break this up into radical 4 times radical 2. Now the reason for that is I pick the biggest perfect square that divides into 8, which is 4. There's nothing bigger. And I know the square root of 4. The square root of 4 is just 2. So the square root of 4, this part here, simplifies to 2, and then we don't know the square root of 2. So we leave it as square root of 2. Just like we left square root of 6 as square root of 6, anything that cannot get broken down stays in under the radical. Square root of 9. We know the square root of 9. It's 3. How about square root of 10? Now, 10 is not a perfect square. Is it divisible by 4? No. 9? No. And so just like radical 6, it cannot get broken down further. It's just radical 10. Next set, radical 12. Biggest perfect square that goes into 12 is 4. So this would get rewritten as radical 4, radical 3. And then we know the square root of 4, it's 2. So this becomes 2 radical 3. 18, not a perfect square. Does 4 go into 18? No. 9? Yeah. It'd be radical 9 times radical 2. And then radical 9 is really just 3, and so my answer is 3 radical 2. Square root of 25. That's easy. 25 is a perfect square. Square root of 25 is just 5. 28, not a perfect square. I go through my perfect squares. 4, yes. 9, no. 16, no. 25, no. So I rewrite this as radical 4 times radical 7. And then radical 4, radical 7 becomes 2 radical 7 because the square root of 4 is 2, and radical 7 we can't break apart. 32. 32 can sometimes be a trickster because 4 divides into 32, but it's not the biggest perfect square. You see, just like in factoring, you need the greatest common factor. In simplifying radicals, you need the greatest perfect square. So 4 works, but 9 doesn't. 16 does. 16 times 2 is 32. So this would get rewritten as the square root of 16 times the square root of 2. What is the square root of 16? 4. And so the answer is 4 square root 2. 40, not a perfect square. What perfect square do you know goes into 40? Is it 4, 9, 16, 25, 36? It's 4. So this becomes radical 4 times radical 10, which then becomes 2 radical 10. 48. 4 goes into 48. 9, no. 16, yes. 25, no. 36, no. Anything further, no. So this is radical 16 times radical 3, which then would become 4 radical 3. 50, not a perfect square. 4, no. 9, no. 16, no. 25, yes. This becomes radical 25 times radical 2, which is then 5 radical 2. Radical 55. 4, no. 9, no. 16, no. 25, no. 36, no. Doesn't look like anything it's going to be divisible by, which is true. 55 cannot be broken down, so it's just radical 55. Radical 60. Now, let's say you weren't sure. 4 definitely goes into 60, but let's say you're like, I'm not sure if 16 goes into 60. You would just divide 60 divided by 16. It's not going to work out nicely. It's going to give you a decimal, which means that 4 would be the greatest perfect square. So it's radical 4 times radical 15, which is then 2 radical 15. The other giveaway is that when you figure out the biggest perfect square, you look at the other number, like 15. If that other number cannot be broken down any further, you know you've picked the greatest perfect square. If it can be broken down, it means that there was a bigger perfect square than what you chose. Okay, square root of 64 is just 8. 72. 72 works with the perfect squares of 4 and 9, but it's not the biggest. What's 4 times 9? 36. 36. So radical 36 times radical 2, which is then 6 radical 2. Radical 90. What perfect square goes into 90? It's 9. So it's radical 9, radical 10, which is then 3 radical 10. 99. 9 totally goes into 99. So radical 9, radical 11, which then becomes 3 radical 11. 120. Okay. So 4 goes into 120. And think about it. 4 times what is 120? 30. Can 30 get broken down by a perfect square? 4, 9, 16, 25? No. So that's how you would mentally figure out what the biggest perfect square is. And then 4 radical 30 is then 2 radical 30. Radical 150. Okay, 4, 9, no, doesn't follow the 9 rule. 16, no, because 16 times 10 would be 160. 25. Think about like $1.50. How many quarters, how many 25s go into $1.50? It's 6. So 150 is radical 25 times radical 6, which then becomes 5 radical 6. Next one, 160. 16 definitely goes into it 10 times. Radical 16, radical 10 is then 4 radical 10. Radical 200, biggest perfect square that goes into 200. Don't get tricked by 4. Okay? Don't get tricked by 25 either. I hope you're saying 100. It's radical 100 times radical 2, which is then 10 radical 2. 256, that is a perfect square. It is the square root of 256 is 16. And then our last one, radical 300. It's just like radical 200. That would be radical 100, radical 3, which is 10 radical 3. I hope this video was helpful. Thank you so much for watching. Bye.